This video is on the separation of variables. Up until now, we've done differential equations with slope fields and with growth and decay, and every single time when we integrated, we made sure that the y variables were with dy and the x variables were with dx, and then we integrated. Well, this is just more examples of the same thing. So if we look at the first one, essentially we're going to cross multiply. So we'll have y dy equals 2x dx. Since the variables are on opposite sides of each other, we can integrate, which will give us y squared over 2 equal to 2x squared over 2 plus c, which we can simplify to y squared over 2 equal to x squared plus c. We can get rid of the fraction, so we're left with y squared is equal to 2x squared plus some constant. Solve for y, so that would be y is equal to plus or minus the square root of 2x squared plus c. Or we can send everything to the other side and have negative 2x squared plus y squared equal to c. Both this one and this one are solutions to our problem. If we look at the next example, we need to send the y over, send the dx over. So they're just going to switch places. So dy over y squared will equal to dx. Now when we integrate, we're going to send this up. So y to the negative 2 dy equal to dx. Integrate it, and that'll give us negative 1 over y is equal to x plus c. To solve for y, y and our x plus c will switch places, so y will equal to negative 1 over x plus c. For our next example, we're going to divide by y and send dx to the other side. So we'll have dy over y equal to x dx. Integrate both sides. So we have 1 over y, which is ln of y, equal to x squared over 2 plus c. We need to get rid of ln, so we e everything. So e to the ln of y is equal to e to the x squared over 2 plus c. Y equals some constant e x squared over 2. Next example, I'm going to rewrite this. So 4y dy dx minus 3e to the x is equal to 0. So I'll have 4y dy equal to 3e to the x dx. Integrate both sides. So 4y squared over 2 will equal to 3e to the x plus c. This simplifies to 2y squared equal to 3e to the x plus c. I can send this over and have negative 3e to the x plus 2y squared equal to c. That could be one way to write the solution. Or I can divide by 2, take the square root, and that'll give me y will equal to plus or minus square root of 3 over 2 e to the x plus c. One more example of a general solution. So here we'll cross multiply, so we'll get 3y squared dy equal to x squared plus 1 dx. Integrate, we'll have 3y cubed over 3 equal to x cubed over 3 plus x plus c. We can then send everything to the left, so we'll have negative x cubed over 3 plus y cubed minus x equal to c is one way of writing the solution, or we can take it as solving for y, and we get y is equal to the cube root of x cubed over 3 plus x plus c. For the next three examples, we're going to find a particular solution to a differential equation. So first we're going to send the e to the negative t dt to the other side. So we'll have x dx equal to 1 over e to the negative t dt, which we can rewrite as x dx equals e to the t dt. Now integrate, so x squared over 2 equal to e to the t plus c. Our next step is to substitute in x and t into our equation. So we'll have, in this case, this one's t and this one's x. So we'll have 1 over 2 equal to e to the 0 plus c. And anything to the 0 power is 1, so 1 plus c is equal to half. Solving for c, we get c is equal to negative 1/2. So our particular solution would be x squared over 2 equal to e to the t minus half, which we can simplify by multiplying everything by 2. We'd get x squared is equal to 2e to the t minus 1. For our next example, we're just going to send the y over, so we'll have y dy equals to 1 plus x over x, and then simplify that, so we'll get y dy equals 1 over x plus 1 dx. Integrate it, so we'll get y squared over 2 equals the integral of 1 over x is ln of x plus x plus c. We're going to substitute in our values. So we have x here, y here, so negative 4 squared over 2 equal to ln of 1 plus 1 plus c. We know that ln of 1 is 0, so we have 1 plus c equal to 16 divided by 2 is 8, so c is equal to 7. So our solution would then be y squared over 2 equal to ln of x plus x plus 7. We can multiply everything by 2, so y squared is equal to 2 ln of x plus 2x plus 14. Solve for y. And that would be our solution. And for our last example, send over the square root of x along with the dx. So square root of y dy equals negative square root of x dx. Y to the half dy equals negative x to the half dx. Integrate it. This would give us y to the 3 over 2 times 2/3 equal to negative 2x to the 3 halves over 3 plus c. Substitute in our values, we have 2 times 4 to the 3 halves over 3 equal to negative 2 times 1 to the 3 halves over 3 plus c. we end up with 16/3 equal to negative 2/3 plus c. Solving for c would give us 18/3. So we have a solution of 2/3 y to the 3/2 equal to negative 2/3 x to the 3/2 plus 18/3. Multiply everything by 3/2. We'd end up with y to the 3/2 equal to negative x to the 3/2 plus 9. We can send the x over, so we get x to the 3/2 plus y to the 3/2 equal to 9. That is the end of this video on separation of variables, and I shall see you soon.